right, so let's stretch. Let's pause the video. You might want to go grab some caffeine. You might really want to kind of kick back and get everything quiet because we got a lot of stuff to cover in this video. This is one of those videos where we're covering too much information in too short of a period of time. I'm going to go ahead and let you know I'm going to cram your brain full of stuff in this video, but at the same time, I'm using this video as an introduction to an entire section. We're about to go off on a thread of like 8 videos of just data types. We had to start somewhere, okay? So this is sort of the somewhere. Okay. All right, so let's just talk about an overview. Okay, so are we talking data types with no space, or is it data types or data types? Which one do you use? I'm going to go with this route. Now, I sometimes will switch it up. Sometimes I will use data types with no spaces. If we were talking a class that I had created, maybe I would use that. But I'm going to go, and I'm not going to suggest you do, but here's what I'm going to go with: data types. Now, I will say this. If you look in the books online, the SQL Server documentation, that is the predominant language. That's kind of why I picked it. Right? To me, this is a more logical thing. I like that better, but that's not the parlance that you're going to see when you start looking in the docs. Okay, so we'll do data types here now. Just understand, this is a very high level overview. I'm not getting into super details just yet. In fact, I'm going to throw a whole bunch of things at you and not explain it. I'm just going to give you a bunch of stuff that we're going to explain in the next sections and even as the course develops. I'm not going to be able to cover everything about every data type in the next 5 or 8 videos. So as the course develops, we'll cover all of the little pieces that you need to know. But let me suggest this to you. This presentation that I'm giving right here is on PDF. It's attached with this video. So just use that as a reference. I've tried to put in here things like the minimums, the maximums, and the size of each data type, of the major data types, so that you could use those as a reference. So just get this PDF, set it aside, and we'll develop what the content is over the next 5 to 8 videos, okay? All right, so we'll talk about, as I said, we kind of covered that. We're going to talk about the details over the next several videos, but we'll also cover some of it in other chapters. I'll give you an example. Like when we get to the spatial data types, we're talking about geography and such. We're not covering that until we get to that chapter. Okay, so that's a long way away from now. All right, now here's the way I think of the SQL Server types. Now this is where I also differ from Microsoft. Microsoft may put these into different buckets. I'm going to put my thoughts into 4 buckets. You're going to store numbers, you're going to store strings, you're going to store temporal, you're going to dates and times, and then everything else. Now, Microsoft obviously is going to have different buckets that they're working from. But this is mentally how I keep track of everything. It's either a number, it's a string, it's some sort of a date time, or it's something else. Now, let's just kind of walk through each one of these buckets. Here's the numbers bucket here. One thing you should know, there's no change in the data types from SQL Server 2005 on. No new data types, no change in the structure, no internal changes, no external changes. Everything's the same. Now, what you have to think about these is that you can classify these in a couple of different ways. The Microsoft documentation will use exact numerics and approximate numerics. That's how they classify these. Now, to me, that I get it. But I prefer to think of these in terms of it's either an integer-based data type or it's a decimal-based data type. So I'm going to introduce both of these. We'll talk about approximate decimal-based and we'll talk about integer exacts, okay? But I prefer the integer and the decimal. Right? And like everything else, we're going to go through specifics later. Use this as a kind of a guide here, right? So this is what I meant. Here's where I am going to give you things like the maximum sizes and the amounts. Okay? Like look at the big int. And we'll just kind of walk in through here. When we say that it takes 8 bytes, I'm being a little bit silly here, and you probably know this, but I just want to make sure. When I say 8 bytes, I mean that a single value in one row in a big int column takes up 8 bytes. But Scott, what if the big int value stores the value 14? Is it still having to store all 8 bytes? Yes. If you have assigned for a column the big int data type, it takes up 8 bytes, regardless of what the value is. Okay. Now, you'll notice over here the maximum and minimums over here. Okay, so this is a big number, so we've got million, billion, trillion, quadrillion, quintillion. I think I got that right. I think that you're talking plus or minus 9 quintillion. Those are the different values that you can store in your big int. Okay. Now the int is half the size, so we're talking of 4 bytes, but we're only able to go to, count it up here, a million, billion. So negative to positive 2 billion. Now we're going to talk later about when I would use int versus big int or versus small int. Okay. Notice the tiny int 0 to 255. What does that mean? It means that there is a domain of values that is of 256 unique values. Okay. And if you start breaking these things down and you start thinking about a byte, okay, here's how I always think about it. Okay. How many bits in a byte? Got 8 bits in a byte, right? How many different combinations of 8 bits are there? Right? What are the values of a bit? Well, you could see it right here. A bit can be either a 0 or a 1. You have 8 bits. How many unique combinations can you create? 256. Okay. And that's where we get 0 to 255. 0 counts, right? So it's 255 plus 0 is 256 unique values. How many unique, I'll start with this. How many bits are in a byte? 8. How many bytes? 2. So we got 16. How many different combinations of 16 bits are there? 65,000 something. Negative 32,768 to positive 32,767. So that's where these ranges come into. And a lot of you might be familiar with signed integers. Well, we don't, and unsigned integers. We don't have unsigned integers here. Like the small int data type isn't 0 to 65,000, for example. It's negative 32 to positive 32. If you wanted to use the integer-based value 33,000, you would then have to go up to using an int. You couldn't mark this as an unsigned small int. Some of you may not know what that means, but others that will make total sense. And just so you know, I didn't write it on here, but the asterisk here, that just kind of means, this isn't really an integer value per se. It could be more considered a special data type. It's a Boolean, true, false, on, off, enabled, disabled, active, discontinued. Okay? But it fit with this description, so I put it right here. So I tend to think of it as an integer here. Now, let's talk about the decimals. I told you this is going to be a long video, so if you need to take, pause the video, grab some coffee, be a good time to do it right now. So let's now move to talking about the decimals. And when you're working with decimals, you're concerned with two things: the scale and the precision. Right? Now, the scale is the number of decimal digits to the right of the decimal point. So like let's just take, oops, I meant to do something else. I'll show you. Like let's take this value here. Okay? This is the scale. So we're defining how many decimal points we want. The precision is the total number of digits that can be stored, and it includes the decimal point. Okay, so the whole thing you're defining is the precision. Now, it defaults to 18. I'm not going to get into what that technically means yet. We're going to talk about that not too far from now when we break down var decimal and numeric and kind of see all the differences and start looking at the length of those. Okay? But there you go. We can go from 1 to 38. Okay? Now, here are your basic exact decimal data types. Aha, remember, there's numeric, there's approximate numerics and exact numerics. That's the way Microsoft broke it down, right? This is an exact decimal-based table. Okay? So we'll talk about approximates here in just a little bit, but notice here, decimal and numeric are the exact same thing. There is no difference. Most of the SQL people will use this term decimal instead of numeric. Most of the Microsoft people, rather, will use decimal instead of numeric. I find that people coming from other languages are often using numeric rather than decimal, but it does not matter. They are the same thing. Okay. All right, so we'll talk a little bit more about the byte size. It depends on what your precision is. We'll do currency. We'll have a bunch of videos that later, all throughout the course, will deal with currency. A lot of us, myself included, have to deal with currency on a day-to-day basis. And we'll talk about why money and small money may not really be good data types for you. They may not be precise enough for you. You may need larger or smaller types. You might be better off using the decimal type to do this. So we'll see, we'll explain what the differences are between money, small money, decimal, and numeric throughout the whole course. We'll be working with those quite a bit. Now we get to the approximate decimals. Okay. These are your floating point data types. Now you have float and you have real. We'll talk about what floating point means. I know some of you guys come in from your computer science classes already very familiar with floating point. But what I get annoyed with is when instructors say, okay, here's your floating point data types, and they just move on. Well, not everybody is familiar with floating point, so we'll cover that again in an upcoming video. Okay? So just kind of use this as a guide, right? Now let's talk about the strings. Again, same thing. No change from SQL 2005 to all the way through R2. You got a couple of different string types. A string can either be Unicode or non-Unicode. Okay? And we'll talk about the differences in an upcoming video. But for the time being, Unicode is a specialized, standardized way of representing text that allows us, if we want to store characters from multiple languages in the same column. That's a hard thing to understand right there. What I mean is that one row of data could be in a Greek, a Cyrillic language. The next row of data could be in Russian. The next row of data could be in English. Now that might not seem special. Okay, well, I kind of assumed that would be the way it was, Scott. But actually, it's a big deal. Okay, what we call localization. We start talking about multiple languages in one column. It's a real big deal. So we're going to spend a lot of time on this in an upcoming video. Okay. But here's what we'll cover here. Notice that these over here have no prefix. It's just char or char, however you prefer. Varchar, varchar. They don't have any prefix. And I'm going to move forward and show you that the next one does. You see the N. The ones that have an N are the Unicode data types. Okay, no N, no Unicode. Okay, going back, see, these are the non-Unicode data types. For the time being, don't worry too much about it. Like I said, we'll cover the full-blown details right here. But so you specify, like with the car, this is a fixed length data type. What that means here with the car N is if I said car 5, I can put up to 5 characters. I couldn't put a 6th character. I would get a truncation error. And it actually takes up 5 bytes of space, regardless of what I put in the column. If I only put in one column, one textual value, like if I just put in the value S, it still takes up 5 bytes of space. Okay? It's a fixed length column. Every insertion takes 5 bytes. Now you couple that or contrast that with a variable length column. Okay, so here we have the varying column, the variable length here, varchar. If I define a column or a data type as varchar 400, I've said I can put up to 400 characters, but my storage space is only equal to about the number of characters that I put in. Like, let's say that we define a last name column as varchar 400, and I say Wiggum. How many bytes of storage does it take up? 1, 2, 3, 4, 5, 6, 7, and a little bit of overhead. About 7 bytes. If we defined this as a car 400, a char 400, then it would take up 400 spaces. Now the varchar max is one of our special data types. For the time being, you can think to look here that varchar and char have a max of 8,000. And so you can say max when you want to go more than 8,000 bytes. And it actually goes up to 2 gigs worth of characters. That's what that really works out to. That's enough bytes to store 2 gigs per column per row. Gosh, I know we're just blazing through this, and again, we're going to cover all of it here in upcoming videos. What I'll say about this one is the Unicode data types are considered double width, also called double byte columns, because for them to actually do the storage, notice that an ncar 5 takes up 10 bytes of space. Notice that this maximum length down here is 4,000, and that's actually a typo. I'll fix that there. Just recognize that. But it has a max length of 4,000 for the ncar and the nvarchar, because they take up twice the space. So you'll see down here that when you're going to exceed 4,000 characters, you're going to use nvarchar max, and it's half the number of characters that the varchar max would be. So double byte, double width. It takes up double the storage to use Unicode. When would you use Unicode? When you store multiple languages in the same column. We'll talk about that in an upcoming video there. Now, kind of winding towards the end here, the date and time data types. We do have new data types in SQL Server 2008. There's no change between 2008 and R2. You'll note these as date and time. And there's too many differences for just a single video. We'll get into these later. But here's your breakdown of the times. Okay, notice the date time 2, the date, the time types. Okay, we'll come into those in a future video. Okay. Now, as for the other types, there's new data types in SQL 2008. There's new data types in SQL Server 2008 R2. And again, too much. We've already gone too long here. So we'll develop through those as the course goes. But what we first need before we jump into a specific data type, we need a quick way to do demonstrations. So I thought, well, let's go ahead and talk about variables in the next video.